So here you see introduction, who is Rust for? Now this is very important. And it says Rust is ideal for many people for a variety of reasons. And you see teams of developers, students, companies, open source developers. And you see how this is very huge in the open source community these days. You see people who value speed and stability. One of the reasons why I like Rust. And then you see, who is this book for? Of course, here is who Rust is for. And then you see, who is this book for? We are not talking about the Rust book. And then you say how to use this book and stuff like that. But let's look at these first. You see, teams and developers. Rust is proving to be a productive tool for collaborating among large teams and developers with varying level of system programming knowledge. Now, I don't care so much about this system programming for now. Okay. Low-level code is prone to various subtle bugs. Very huge. You know, when I'm talking about low level, I'm not really talking about assembly language for now. I'm talking about something like C language, C++, and so on, which in most other languages can be caught only through extensive testing and careful code review by experienced developers. Pay attention to this experienced. Now, this is a huge barrier for entry, especially these days. If you see C++ developers, for example, they're mostly people who are well experienced before you can identify as that, because it takes a lot of time to master how to, especially when it comes to memory management. It's one of the reasons why. So it's not about knowing the language. It's also about knowing how to handle memory. And that, no matter how experienced you are, it's usually an issue, a very huge issue which Rust is trying to solve. Now, if you are doing system programming, low-level stuff, this is where it comes in very handy. Now, the compiler plays a gatekeeper role, very important, and you see how this works. I'm talking about Cargo, which is the compiler, Rust compiler. The compiler plays a gatekeeper role to refuse to compile code with these elusive bugs, including concurrency bugs. Now, how the Rust compiler behaves is, if it believes that your code is not going to work, it will not compile at all. And of course, you know, you have interpreted languages and then you have compiled languages. Languages like PHP, Python, JavaScript are all interpreted. You don't need to compile them. Once you write them for JavaScript, you run them in a node environment or in a browser. The PHP, you run it on say Apache server or whatever, and then it will run. But for languages like Java, C++, and Rust, for example, you have to compile them to a runnable binary for them to work. So these ones that you have to compile, especially when it comes to Rust, the Rust compiler will not even compile. If it decides or realizes that you might have a bug, it's not going to compile. And this helps you a lot. So you no longer have to compile your code and then run the code before you figure out what is going on. It will tell you immediately, and then you will know what is going on and fix it before you even compile your code. So by working alongside the compiler, the team can spend their time focusing on the program's logic rather than chasing down bugs. Very important. Bugs are exactly what it sounds like, bugs. They are very, very elusive. You know, sometimes you won't even realize it until your code is in production. So that is where Rust comes in to help you in this. Now, Rust also brings contemporary developer tools to the system programming world. So you might say that Rust is relatively new, yeah, but it comes with a lot that helps you get going immediately. For example, you have Cargo, so which includes the dependency manager and build tool, makes adding, compiling, and managing dependency painless and consistent across the Rust ecosystem. So Cargo is like NPM for Rust, but it's not just a package manager. It also handles the build tool and helps you with compiling your code. So for example, in Node.js or JavaScript, you have NPM, which is the package manager, but you also have some other things like Webpack and Vite, for example, which helps you compile. If you're writing TypeScript or if you want to compile down your code to JavaScript, let's say you want to uglify your code or so, something like that. If you're writing React, for example, you have to compile it down to something you can run easily. We have something like Webpack and Vite for that. But Rust has all these in Cargo. It helps you with dependency management and so on, and for building. Then you have the Rust FMT for formatting. So this is, when it comes to Node.js, it will be something like ES length fix, or maybe pressure. And maybe in PHP, you have the PHP code beautifier. and so on. That is what the Rust FMT is. This FMT means formatting. So it's Rust formatting tool. And then you have the Rust server. Of course, every language you have their language server. So usually you won't worry about this if you're using a high level IDE, something like VS Code or IntelliJ. But if you're using something like Vim or NeoVim, then you have to install a language server, which helps you with the language to make sure that you're writing code that will work in the language. So Rust also have a language server that you can use. But usually if you're in VS Code or IntelliJ IDEs, you usually don't really need to worry about it because they already take care of it. So pay attention to cargo. We are still going to cover it in detail. The Rust formatting. You don't really need to worry about this. Once you get it going, that's all you have to do. And the rest, so you're going to use VS Code mostly, so you don't need to worry about this again. But we are going to cover cargo in detail, how you create packages, how you add dependencies and stuff like that, and how you manage them. So by using these and other tools in the Rust ecosystem, developers can be productive while writing system level code. So Rust is matured, for building stuff. Now, another demographic it targets is students. Now, here it says Rust is for students and those who are interested in learning about system concepts. Now, when we are talking about system, we are mostly talking about low-level stuff, the operating system, the kernels, and so on. If you're interested in that, then Rust is very huge for something like that. You no longer need to worry so much about C++. Okay. Now, using Rust, many people have learned about topics like operating system development. Now, the community is very welcoming and happy to answer students' questions. Now, the Rust community is a little bit, I would say it's more friendly when compared to other language communities. They're always ready to answer your questions and stuff like that. Rust have a very high barrier, a very high steep learning curve. And so, surprisingly, people in the community are very friendly. So if you have issues and ask questions, there are always people there to answer the question. They won't really give you the Stack Overflow vibe of trying to talk you down when you have simple questions. But anyway, now, through efforts such as this book, the Rust teams want to make system concept more accessible to more people, especially those who are new to programming. So if you're a student, you can go into Rust. However, I will talk about this in detail later on, about the fact that if you're not really experienced in any other programming language, then going into Rust is going to be very, very hard. In fact, I really don't recommend it, but we'll still talk in detail about it and how you can approach it. So if you're thinking about learning your first programming language, you can get started if you really want to learn Rust. Now, and that is what this channel does for the most part, because you see, I'm not really focusing hugely on the high level stuff. I try to go, that is why we are covering this book. So we are going to go through this whole book with tons of examples. And I'm also thinking of setting up quizzes that you can take, because it's not just about learning stuff. You have to practice. If you just learn it and you don't practice, you start forgetting them and it becomes an issue. Anyway, now you also have companies. Now hundreds of companies, large and small, use Rust in production for a variety of tasks, including command line tools, web services, DevOps tooling, embedded devices, audio and video analysis, and transcoding, cryptocurrencies, bioinformatics, search engines, Internet of Things applications, machine learning. So in case you're from Python and you think it's only Python that can do all this, Rust is also huge in that, and even major part of Firefox browser. Now Rust, when it comes to machine learning, of course, there has been this huge debate if we can easily use Rust. Python is really good for stuff like this, but I don't like Python because it's not statically typed. But a lot of people use Python for machine learning, AI stuff. And moving from Rust to Python, especially for someone who is only a Python developer, it's probably going to be very, very hard, because if you are talking about the most statically typed language, the strictest is Rust, if you ask me. And so it's not going to be that easy. So the move of most people in the machine learning community to Rust from Python is actually very far-fetched. But anyway, it's still there if you want to exploit. Of course, I use Rust for many things. If you look here, you see embedded devices. And this one is also very huge. So as some of you might know, I'm very huge in electronic circuit design and programming embedded devices. Now, I use Rust for this as well. And the reason why I went into Rust is so that I can use it for every single thing. So I spend a lot of time thinking about what language to learn before I even started Rust. Especially these days, you learn, over the years, I've used all kinds of languages. I started with assembly language for many years, programming microcontrollers and building electronic circuits. So I design and build electronic circuits. So I was using assembly language for about 4 years or so. And later on, I started using C++ and C language and so on. And Rust has come to your rescue. And the beauty about Rust is that even though you are using it for microcontroller programming, in this case, for example, it doesn't really produce very huge code, because it's also an issue with C++. If you write your code in assembly language and write it in C, the one you write in C, when you compile it down, is going to be huge compared to that you write in assembly language. Now, these days, with some microcontroller modules that have enough memory, it might no longer be a very huge issue. So this is where Rust comes in. You can use Rust and VS Code to program embedded devices, but we'll still come back to that because it's also a very huge stuff I want to explore in this channel and so on. You see DevOps, you see web services. I will also be building a lot of APIs with Rust as well, cryptocurrencies and so on. So you see you add that fix, and you can see what they said here, Firefox browser. So Firefox have been introducing Rust, using it to build some part of their browser tools and so on. Now you have open source developers. Rust is for people who want to build the Rust programming language. Community, developer tools, and libraries. We love you to contribute. You are free to contribute to Rust. So Rust is open source. So even though sometime last year you had issues with the Rust, the organization, where they were trying to limit people from using the Rust logo or even the Rust name and stuff like that. But it looks like they've scrapped that idea because it wasn't a good idea. I also talked about it on Twitter then. So people who value speed and stability, Rust is very fast. In fact, one of the reasons why people decide to use Rust. Rust is for people who crave speed and stability in language. Now, there's this popular saying in Rust that once your code compiles, then you're almost certain it's going to work. As long as the business logic in your code is correct, you will no longer worry about it that much. You see, for example, JavaScript. You have your code in production, and after a while, you start having all kinds of errors. You hardly get that with Rust because the compiler does everything it can to limit something like that from ever happening. And by speed, it means both how quick Rust code can run and the speed at which Rust lets you write programs. Now, of course, if you've tried Rust before, this part will be a little bit funny. It says, and the speed at which Rust lets you write programs. Let's be frank, if you are new to Rust, you're not going to be writing a lot of codes at a very high speed because the compiler is going to, frustrate you to a very high level that many people will quit Rust, of course, when you start. It's not going to allow you to compile codes, because if you have any simple error, it's not going to allow that. So you're going to have issues with that, but once you start getting the hang of it, it will be faster for you to write code in Rust and so on. The Rust compiler's checks ensure stability through feature addition and refactoring. Now, this is very important. You know that sometimes you write code very fast. Maybe how fast you write the code is probably not going to be an issue for you. But the problem is fixing bugs. It takes a very huge time to fix bugs and finding out when things how to go wrong. So you spend time making sure that your code is going to work. But when you use Rust and the compiler does most of the heavy lifting for you, you're no longer going to worry so much about what might happen or what might not happen, and so on. So this is in contrast to the brittle legacy code in languages without these checks. So quick developers are often afraid to modify. We've all been through this. You see a legacy code and you're afraid to touch anything inside there, because once you do, you could spin up a domino effect and start a chain reaction that you're probably not going to be able to fix later on. So, but Rust makes it easier, especially. But even with Rust, something like that can still happen, but it helps a lot. The compiler does help in this case. By striving for zero cost abstraction, high-level features that compile to low-level code as fast as codes written manually, Rust endeavors to make safe code be fast code as well. Yes. Now, in Rust, you start hearing stuff like safe code. You usually don't hear this with other languages. And why the Rust talks about safe code means it doesn't 100% guarantee that your code will not, you're not going to have issues with your code in production. But it does way more than other languages to prevent that from ever happening. And that is why it can be very, very strict. Now, the Rust language hopes to support many other users as well. Those mentioned here are merely some of the biggest stakeholders. So overall, Rust's greatest ambition is to eliminate the trade-off that programmers have accepted for decades by providing safety and productivity, speed, and ergonomics. Give Rust a try and see if its choices works for you. Now, this looks like an advertisement, but it's okay. The Rust community is getting bigger, especially when it comes to, open source developers. You see many other people going into Rust, Vite, I guess, Webpack, and many others are going into Rust, especially using it to build software engineering tools and so on. Now, who is this book for? This is very important. In fact, if you're going into Rust, I suggest that you do this book first. But I've also noticed that many people find it difficult to go through, and that is why I'm starting this series to make sure that I help guide you through this. I've covered this in many other videos, but those videos are not high quality, and I've not had the time to continue it for a very long time. So that is why I want to go. We're going to cover everything here, so that if you start reading this on your own and you have issues, you can only reference the videos and then fix it up. So let's just cover this. Now it says, who is this book for? This book assumes that you've written code in another programming language, but doesn't make any assumption about which one. Very important. We've tried to make the material broadly accessible to those from a wide variety of programming backgrounds. We don't spend a lot of time talking about what programming is and how to think about it. Now, very important. So it talks about general knowledge, but does it in such a way that you fit in. Now, you see what it said here, that it assumes you've written code in other programming languages. That is why I said before, if you've not written code in other languages, Rust is going to be, let me make it very simple, it's going to be very hard for you. And you will have some level of tenacity to be able to go on with it. Most people will quit before they even get there. But if you're coming from other languages, give it time. Even if you're not understanding it, go through it, let her come back, and then you can proceed and start understanding it even more than before. If you're entirely new to programming, you'll be better served by reading a book that specifically provides an introduction to programming. Yeah, of course, they have to say it here. I will advise you, don't really go into Rust if you don't know other languages first. However, if you have the tenacity to be able to face hard stuff and go through with it, then follow these videos, in fact, and that will help you. If you just jump into this book and start reading them and start practicing it, you're going to find it difficult. Okay, that is what I just want to make clear.